Welcome to the world of artificial intelligence in banking. Imagine you swipe your credit card at an ATM. In less than 100 milliseconds, an AI system has to answer one critical question. Is this transaction genuine or is it fraud? If the system blocks a legitimate transaction, the customer becomes frustrated. If it misses a fraudulent transaction, the bank could lose millions of dollars. This is where artificial intelligence, machine learning, and MLOps come together to protect modern financial systems. In this video, we will explore how leading banks use AI models in real time, how these models are deployed, monitored, retrained, and why MLOps has become one of the most valuable and highest-paying skills in the AI industry. But first, what exactly is MLOps? Think about traditional software development. Developers write code, test it, deploy it into production, monitor its performance, and continuously improve it. Machine learning models require exactly the same life cycle. Data changes, customer behavior changes, fraud patterns evolve. Without proper management, even the best AI model will eventually become outdated. This complete operational life cycle is known as machine learning operations, or MLOps. The journey starts with business data. That data is collected, transformed into useful features, and used to train machine learning models. The models are validated, deployed into production, and begin making real-time predictions. Their performance is continuously monitored. If the system detects that the model is losing accuracy because the real world has changed, it identifies model drift and automatically triggers retraining. This creates a continuous feedback loop that keeps AI systems reliable and accurate. Now let's look at one of the most important applications of AI in banking: fraud detection. Imagine you are purchasing a laptop worth 1,50,000 rupees in Hyderabad. Before the payment is approved, the AI system instantly analyzes multiple pieces of information. It checks your transaction history, it verifies the merchant category, it analyzes your device fingerprint, it reviews your GPS location, it compares the transaction amount with your normal spending behavior. It studies your card usage patterns. To achieve this, banks use powerful machine learning models such as XGBoost. XGBoost is widely used because it provides high prediction accuracy, extremely fast inference, and performs exceptionally well with banking transaction data. Random forest models help detect abnormal transaction patterns and classify risk. Neural networks identify highly complex fraud behaviors that are difficult to capture using traditional methods. Behind the scenes, every ATM transaction enters a real-time data pipeline. Apache Kafka streams the transaction data. A feature store provides standardized customer features. The XGBoost model evaluates the information and generates a fraud score. If the score is extremely high, the transaction is blocked. If the score is acceptable, the payment is approved instantly. This technology is critical because global banks lose billions of dollars every year due to fraud. Even a small improvement in AI accuracy can save millions. Another powerful application of AI is instant credit scoring. Imagine applying for a personal loan online. Years ago, you might have waited several weeks for approval. Today, AI can provide a decision within minutes. Banks often use logistic regression because it is highly explainable. If a customer asks why a loan was rejected, the bank can provide clear reasons. Perhaps the credit score was too low, maybe the debt ratio was too high, or income patterns were unstable. At the same time, banks use XGBoost to improve prediction accuracy. Many financial institutions combine logistic regression with XGBoost to achieve the perfect balance between explainability and performance. The AI system evaluates credit history, salary, existing loans, EMI obligations, account balances, and spending habits before making a recommendation. MLOps ensures that every decision is fully traceable through model versioning, audit trails, regulatory compliance, fairness monitoring, and automatic retraining. Next comes anti-money laundering, commonly known as AML. Banks process millions of suspicious transactions every day. Human analysts simply cannot review them all manually. AI systems identify unusual transfers, multiple small deposits, round-tripping activities, cross-border anomalies, and suspicious account behavior. To accomplish this, banks often use ensemble learning. combining random forest, XGBoost, rule engines, and isolation forest algorithms. However, AI does not replace humans. Instead, it works alongside them. The AI model flags suspicious activities, and compliance officers perform the final investigation. This partnership significantly reduces false positives while improving detection rates. One of the most important components of MLOps is the feature store. Imagine two different teams calculating the same customer spending value. One team calculates 10,000 rupees, another team calculates 11,000. Which value should the AI model trust? A feature store solves this problem by creating a single, consistent source of truth. Technologies such as Apache Spark, Apache Kafka, Redis, and Amazon S3 help manage these features in real time. This ensures that training data and production data remain consistent, prevents train-serving skew, and accelerates AI development. Another essential component is the model registry. Think of it as GitHub for AI models. It stores model versions, training datasets, hyperparameters, accuracy metrics, deployment history, and approval status. Popular tools include MLflow, Kubeflow, and AWS SageMaker Model Registry. As time passes, fraudsters evolve their techniques. Customer behavior changes, markets change. A fraud detection model trained 2 years ago may slowly become less effective. This phenomenon is called model drift. MLOps continuously monitors accuracy, precision, recall, data distributions, and customer behavior. Using statistical techniques such as the Kolmogorov-Smirnov test, population stability index, and Jensen-Shannon divergence, the platform automatically detects when a model begins to degrade. When drift is detected, an alert is generated. The model is retrained. The new version is validated. Finally, it is deployed back into production. This entire process happens automatically. Deploying AI models also requires a disciplined pipeline. The journey starts with development and code review. It continues through CI/CD automation and staging environments. Before releasing a new model to all users, banks perform canary deployments. Instead of sending 100% of customer traffic to the new model, only 5% is routed initially. The system is monitored carefully. If everything works correctly, traffic gradually increases to 25%, then 50%, and eventually 100%. This approach minimizes production risk and protects customers. Modern MLOps platforms are powered by an extensive technology stack. Data is processed using Kafka, Spark, Hadoop, and S3. Feature stores are built with Feast and Redis. Machine learning models are trained using scikit-learn, XGBoost, TensorFlow, and PyTorch. MLflow tracks experiments. Docker packages applications. Kubernetes orchestrates deployments. Jenkins and GitHub Actions automate CI/CD pipelines. Prometheus and Grafana monitor production systems. Cloud platforms such as AWS SageMaker, Azure Machine Learning, and Google Vertex AI provide enterprise-scale AI infrastructure. The demand for these skills is growing rapidly. Banks, fintech companies, insurance providers, healthcare organizations, e-commerce platforms, and cybersecurity companies are investing heavily in MLOps. Organizations are no longer looking only for software engineers. They need professionals who understand artificial intelligence, machine learning, cloud computing, Kubernetes, data engineering, and MLOps. The future of AI is not just about building smart models. It is about operating them reliably at scale. Artificial intelligence makes predictions. Machine learning learns from data. MLOps ensures these systems remain accurate, secure, explainable, and continuously improving. That is how modern banking is being transformed. And that is why MLOps is becoming one of the most important technologies of the AI era.